Probability and the Addition Rule by Justin D'Souza. The learning objectives of this lesson are to apply the addition rule to situations involving mutually exclusive events and the same thing with that are not mutually exclusive. Here, very important thing is about mutually exclusive and not mutually exclusive. The keyword is the same, mutually exclusive. Let us look into the events which are mutually exclusive or not mutually exclusive. You might have heard the word exclusive, something unique, right? Now, mutually exclusive means two events which are not at all dependent or do not have any common things between them both. Whereas not mutually exclusive means they having some common terms or common events occurring. Let's look into an example over here. When you're rolling a die, the probability of getting 3 or a 4, the probability of getting 3 will never affect the probability of getting a 4. And we cannot get a common number. We don't have a number in die which is 3 and 4. It's all mutually exclusive. They are separate. But if I would say probability of getting a even number and probability of getting 2, then it is mutually they are not mutually exclusive, because 2 is an even number and 4 is an even number and greater than 2, so I can say that is not mutually exclusive. But getting 3 and 4, they are mutually exclusive. There is no way they can have a common term. So in such cases, all you need to do is, or means add the probabilities. You're adding the probability. The probability of getting the 3 is 1 by 6. Probability of getting 4 is also 1 by 6. So you basically add them both, or is to add 1 by 6 plus 1 by 6 is basically 2 by 6 or 1/3. The formula of mutually exclusive events, the events which are not having anything common, is just by adding it. Probability of A plus probability of B. That's it. Now let's look at these statements and see if they are mutually exclusive or not mutually exclusive. Here, a card is drawn from a standard deck of 52 cards. We have seen about cards in the previous lessons. There are 4 suits, 1 to 10 number cards and 3 picture cards. Now here there is a statement drawing a 3 or a 2. Is there any card which is both 3 and 2? No, 3 is a separate card, 2 is separate. They cannot be they cannot be the same. There is no common, so they are only mutually exclusive. Okay, mutually exclusive. So the formula would be probability of A plus probability of B. That's it. Whereas drawing a 7 or a red card, is there 7 and red common card? Yes. 7 of hearts or 7 of diamonds would be common, right? 7 of diamonds or 7 of hearts. So this is not mutually exclusive. Why? Because there's a common thing. 7 of hearts and 7 of diamonds is the common. Now for this, the formula would be P of A plus P of B minus P of A intersection B. We will see this in a while when we solve not mutually exclusive problems. Now drawing a queen or a spade. There is a queen which is of spades, isn't it? So now what happens? This is a common card. So this is also not mutually exclusive. If there is no common cards or no common events, then it would be mutually exclusive. So this is mutually exclusive, the first one, but all the others are not mutually exclusive. This is not, and this is also not mutually exclusive. Now let's look into a problem, another real world problem here. Daniel organizes all of his social media contacts into 3 groups. Okay, here we can see 1, 2, 3 groups are there. If the program sends Daniel an update from a randomly chosen contact, what is the probability that the contact is either a close friend or an acquaintance? Now, close friend, acquaintance, and restricted people. So he has, separated his friends list. Close friends are his close buddies, whereas acquaintances is someone you know from maybe a friend's friend, but you don't know him very closely. Okay, so you call him acquaintance. Restricted is someone you're blocked, basically. Here, what are the total? First, let's find the total number. It would be just 68 plus 24 plus 10. That would be 60, 80, 90, 102. So the total is 102. Now here, the probability of what is asked, the probability of a contact who is close or acquaintance, close friend or acquaintance. They both are not the same. There is no common. There are 68 close friends. They are separate. Acquaintances separate. They cannot be both together. No, they are separate, isn't it? So the probability of A or B, because they want close friend or acquaintance. A, let it be close friend. B, let it be acquaintance, would be probability of A plus probability of B. In the last lesson, we did multiplication rule. That was AND. We generally consider AND for multiplication or for add and subtract. In physics, you might have come across AND gate or gate. AND is basically, multiplication, or is related to addition. Now here, this is the formula. What is the probability of getting a request from a close friend? 68 is the desired outcome divided by the total, that is 102, plus here it is 24 divided by 102. So you just add 64, 80, 92 divided by 102 is the answer. You can put in the calculator and find the percentage as well if needed. So that is the answer. You can see the total contacts are 102, and this is the formula for the probability. Oh, you can simplify this. Sorry, 2 is common over here. It would be 46 by 51. That is the answer. Or 90%. There's a chance, because you can see majority of his friend list are close friends or acquaintance, so it's more than 90%. Here, another similar problem, biodiversity of more than 79,800 species of red list. On a red list of threatened species, seabirds are of particular interest because they are the indicators of broader marine health issue. The circle graph shows the portion of seabird species in each red list category. What is the probability that a randomly selected species of seabird is on the critically endangered or endangered list? Here we just need to find the probability of critically endangered, whereas this is the one, or endangered. So these are the two probabilities. What is the percentage of probability? Already percent is given. It's 5 plus 9. It's basically 14%. Why? Because the formula is P of A plus P of B. This is the probability of event A or event B, critically endangered or endangered list. So answer is 14%. It's very simple and straightforward. There's nothing much to do in this. Now we will go to the probability of not mutually exclusive events. Before we continue, a quick reminder and a request to subscribe to my channel. Only 10.4% of the viewers are subscribed, whereas 89.6 are not. If you're subscribed already, thank you so much, and I would highly appreciate if you could like the videos and share it among your friends. Now, about not mutually exclusive events. Here, if you have two events and there are common terms, then they are not mutually exclusive. Over here, I had given this example, greater than 2, or it's an even number. So you can see greater than 2 can be 3, 4, 5, 6. Even numbers are 2, 4, 6. But 4 and 6 fall in this criteria, right? Where they are same. So in such cases, we use this formula of the first event, the probability of the first event plus the probability of second event minus the common terms, that is A and B. Then we will get the answer. We will look into a problem now. So this is the formula here. P of A or B is P of A plus P of B minus P of A and B. This is for not mutually exclusive events. Here we have a problem about game pieces that is selected at random from this plate. What is the probability that the game piece is round and orange color? You can see there are some round ones and orange color. Let's count the total number first. It's 4, 5, 6, 7, 8, 9, 10. Okay, total is 10. Let me write the first event. Probability of a round. Probability of round is equal to, there are 5, right? 1, 2, 3, 4, 5. So that is 5 out of 10. Then what is the probability of orange color? There is 1, 2, 3, 4. 1, 2, 3, 4. So it's 4 out of 10. Now, do we have any probability of round and orange? And orange, that is basically intersection. It is basically P, A, or and B. This is the thing. You can see these two are round and orange, only two of them. So that is 2 by 10. Now we know from the formula probability of A or B for not mutually exclusive, because there are common terms. If it's not mutually exclusive, we have to do probability of A plus probability of B minus probability of A intersection B. This is the concept. Now here, what is probability of A? Now why do we do this minuses? Let's think about it. Let's analyze it. Probability of A is of all the round objects. I've used 1, 2, 3, 4, 5. So 5 by 10. Plus probability of B, I've used 1, 2, 3, 4 by 10. But can you see this? This I used two times. One time I used okay. In the next time I shouldn't have used it again because I already used it once, right? Now I'm again using it. That means this is used twice. So I'm subtracting whatever has been used twice. That is 2 by 10. That's it. Now if you solve this up, 5 plus 4 is 9, minus 2 is 7 by 10. You have 0.7 probability of getting a piece that is round or orange, or it is 70%. This is how we solve. This is an important factor, that is P of A intersection B, that has to be removed because we are using it twice right over here. Only one time we need, so we subtract it. The answer should be 70%. Let's check it out. Yes, it's 7 by 10. That's enough. It's 70%. Now, the last problem in this lesson, an interesting problem. I really like this. What do we have over here? We have 8 different shapes. We have to find the probability of each set of events. Okay. Now, over here they have given us the situations, and we need to find the probability for these two events. And over here they are not mutually exclusive because I have mentioned it. But let's read it out first. Choosing a figure that has more than 4 lines of symmetry. 4 lines of symmetry. Now, how do we understand how many lines of symmetry does all these shape have? First of all, before we go there, they all look like regular shapes in the sense all the sides are equal. Okay, let's consider them to be regular. And over here, this is a triangle. This is triangle with 3 sides. Now let me write 3 sides here. This is having 4 sides. Just write it in the smaller ink. 3, 4, 5, 6, 7, 8, 9, and 10. Okay, they have just increased by 1. You can see them. They are these shapes. So how do we know how many symmetry lines are there? If n is number of sides, then lines of symmetry will be same as the number of sides. Let's try over here. How many lines of symmetry? I can draw 1, 2, 3. Number of vertex, right? Now here 1, 2, 3, 4. 1, no, sorry. It should be, that's not a line of symmetry for pentagon. Oh, that was very bad. Okay, over here. 1, 2, 3, 4. No, that is done. 4 and 5. Okay, depending on the number of sides. So this is in general you can consider to be formula. N is the, based on the number of sides you can draw lines of symmetry. And now that is one situation. So how many has more than 4? It's not equal to 4, more than 4. It is 1, 2, 3, 4, 5, 6. So probability of event A plus probability of event B minus the common, right? A intersection B. So what is probability of event A? That is 6 out of 8. Fine. Let's go to the next one. What is the probability that the shape has more than 7 sides? Here 7 sides is heptagon. This is hexagon 6, heptagon is 7. Now octagon onwards have more than 7 sides. So that is 1 octagon, nonagon, and decagon 3. So the probability of this is 3 by 8. Now what are the common terms, common shapes? You can see 1, 2, 3, 4, 5, 6. The last three are common, that is the octagon, nonagon, and decagon. So minus 3 by 8. So the answer is 6 by 8. That's it. So for the first one, the answer is 6 by 8. I hope this is clear. Now let's do the next one as well. The second probability is very simple. Sides, just remember line of symmetry based on number of sides. Now choosing a figure that has more than 15 diagonals or total interior angle measured greater than 900 degrees. Do you remember the second one? We had done it in the last term. The formula is given as n minus 2 times 180 for the interior angles, 180 degrees. But what is the formula for the diagonals? There is a formula which will work all the time, that is n into n minus 3 divided by 2. So this is the formula, but many of you may not remember this formula. So what you can remember is, you can try drawing the diagonals directly. Let me just erase this out. Let me just draw diagonals over here. What is a diagonal? Which must cross the opposite vertex, not the adjacent vertex. It must be other than the adjacent vertex. Is there any other than adjacent vertex for a triangle? No. You can't have any vertex for a triangle, but this one, you can draw over here or over here. This is a diagonal. And this, two diagonals. Now over here, I can't draw to its adjacent. If I'm considering this point, say, I can't draw this and this. 1, 2. That's diagonals. Over here also. 1, 2. 1, 2, 1, 2. Basically, all the sides over here will have two vertices, so it'll be 10. What about this? It'll be 1, 2, 3. Then over here also 1, 2, 3, and you can count like that, okay? All the diagonals. If you can't remember this formula, but if you know this formula, it's so easy. Plug in for triangle, what is it? N is number of sides. 3 times 3 minus 3 divided by 2, it will be 3 minus 3 is 0. 0 is the answer. What about square? 4 into 4 minus 1 by 2. 4 minus 1 is 1. So it's 4 by 2. That's 2. 5. Pentagon. 5 minus, this is 3, sorry. 5 minus 3, yeah, it's 1. Yeah. What about pentagon? 5 minus 3 again. So it'll be 2 by 2. So it'll be 10 by 2. It's 5. Yes, it has 5 diagonals. You can keep on going over there with the next ones. It'll be 6 times 3 is 18, 9. Now, what do we want? More than 15 diagonals. So, how much does the heptagon have? Heptagon is 7 times 7 minus 4 is 4. 7 minus 3, sorry, is 4 by 3. 7 fours are 28 by 4. It's 14 diagonals. Now then, from octagon, we will have more than 15 diagonals. Okay, let's do it. Octagon is 8 into 8 minus 3 would be 5 by 2. So if you do 8 times 5, it's 40. 40 by 2 is 20. This is more than 5. So which are the possibilities? That will be 1, 2, and 3. Let me write the formula: n into n minus 3 by 2. So we have only 3 possibilities which have more than 15 diagonals. But now what is the angle more than 900 degree? The formula is n minus 2 times 180, right? Let's do this. So here it will be n. Let's try with the, because obviously we need greater than 900. I'm sure this is not, because I know this is 360 degrees. Now this also you might know. Let's try with heptagon or something like that. Let's do 7 minus 2 times 180. It is basically 5 into 180. 18, it's basically 18 times 5. It's 90. 900 would be the answer over here. Now 900 degrees, but this is not considered. Why heptagon is not considered? We need more than 900, greater than that. So again, it will be 1, 2, 3. It will be the octagon, nonagon, or decagon. These three have more than 900 degrees. So over here, probability of event A, the first probability, this is 3 by 8 plus again 3 by 8, and the common terms are also 3 by 8. So minus 3 by 8. Basically, the answer is only 3 by 8 over here. This is the answer, 3 by 8. The first one was, I believe, 6 by 8. So these are the answers. And last one, This is easy one because it's parallel and diagonals. Choosing a figure that has more than two pairs of parallel sides, which have parallel sides over here. Now remember, if there are even sides, only then you will have more than at least two parallel sides. See over here, parallel. Don't think this is parallel or pentagon is parallel. No, they are not parallel. Only when there are even sides. See, like a like a quadrilateral, hexagon, octagon, you will have parallel sides. 1, 2, 3, 4, 1, 2, 3, 4. These are all parallel. So we need more than two pairs of parallel sides. I will just erase this up. So it is either one, this one, two, or three. There are 3 out of 8 parallel sides. Now, which all have more than one diagonal? This is not there. This has 0 diagonal. This has 2 diagonals. So 1, 2, 3, 4, 5, 6, 7. All the 7 are considered. All 7 out of 8 have more than one diagonal. But how many have two pairs of parallel sides? Plus only 3. 3 by 8. Minus which are the common terms? This is common 1, 2, and 3. Minus 3 by 8. So the answer would be 7 by 8 here. So these are the answers. Let's just look into the answers. It is in percentage. Don't worry, we can use the calculator and just put this. Over here it is simple. Yeah, it will be 3 by 4, it's 75%. But others, we can just put in the calculator and solve it now. This is 3/4, that is 75%, very direct. 3 by 8 would be 0.375. When you multiply it by 100, it is going to be 37.5%. Same way over here, each part, because it's divided into 8, right? Each part will be 12.5%. So 7 means 87.5, 12.5% is missing out of 100. So you can even try that directly in the calculator. It's 7 divided by 8, that is 0.875, that is 87.5%. I hope these problems are clear. This is how you solve them. Only this one is a bit tricky because there's a lot of geometry involved. Please try to recall the formulas which you have studied before. If you have not studied this, you can remember, or you can use these figures directly and try and draw the diagonals or whatever is required. So that is the end of this lesson. I hope you have found this beneficial. If you have found it helpful, please do share it among your friends. Let others also benefit from these videos. And please do hit the like button. And if you're not yet subscribed, please do subscribe. Until the next video, wish you all happy learning.